Yes. Hello. Can everybody hear me? Okay. Well, thank you, Katrin, and thanks to all the previous speakers here. And welcome, hello, to this last session for those of you who just joined, and for the others of you, just hang on. It's almost done, half an hour left. And we'll be looking at PointSense Plant now, which is an industry-specific solution for the plant and piping industry. And before I start, I will have a look at this typical workflow within this industry, basically. Well, first of all, there's the measuring on the one side, which is basically just bringing the reality into the computer, which is laser scanning, photogrammetry, or tarimetry. And the next step is the very interesting one, which is something which we had a look on today already. And on the far right side, we have the planning, which is a particular important point in the piping or plant industry, because you work with design software, you have to do management, simulation, and so on. And the question is often, how do I get from one side to the other? So basically, how to get from the reality into my planning software. And well, basically the optimal workflow would be to have the point cloud on the left side, and on the other side to have the design software. And there is some gap, which we can see here. And in order to close that gap, PointSense Plant has been developed. And once this gap is closed, we can use our point cloud data in order to create a 3D model to do simulation, visualization, or for example ISOs, and so on. So what is PointSense Plant? Just quickly, PointSense Plant basically helps the user to convert a point cloud into plant-specific CAD objects, and it closes the gap between a stupid 3D point cloud and the design software, for example, AutoCAD Plant 3D, and which mostly works with intelligent objects. And PointSense Plant also works as the other PointSense products directly in AutoCAD and is based on catalogs. Yes. So here are some of the features. So we have an integration with catalogs, which I'll be showing in a second. We have an enhanced VirtuSurf interface, something we'll be seeing in a second, but something that has been shown previously today already. But for those of you who just joined, I'm going to show a few features again of that. And we have pipe run analysis, which is the main feature, let's say. Some of you may be familiar with that already, but there have been some improvements. Then we can determine tie-in points very precisely in combination with VirtuSurf. We can export and import Plant 3D catalogs. We can generate center lines and also tag the extracted pipe run. We also have some new steel features which are very interesting. I'm going to show them later as well. And as well the tank analysis, which is a feature that has been requested by many of you and is particularly of interest for people working in this industry. But there's many more, so my slide is only that big, so I can't show everything. But within the PointSense Plant, there's also the slicing, the section manager, the basic modeling tools that you've seen previously, so that is included as well. Okay, so now VirtuSurf, for those of you who haven't seen it, or those of you who are familiar with it, this is basically a planar view of the point cloud, and that often helps you to get a more relaxed workflow without hesitating, I don't know, rotating the point cloud and so on, and sometimes a bit easier to work with this planar view. So it's a photorealistic view, and you have a point cloud basically, or 3D points in the background, and you can send those to AutoCAD, which you have seen before, and it's very accurate to generate tie-in points with that. And also there's a scan map that allows you to navigate more easily through your large projects. I'll be showing that in a second. So hopefully that works now. I'm going to switch to VirtuSurf. So this is VirtuSurf here, and in this case I have two scans open. This is actually like a industrial facility here, some piping and some steelwork and so on. And here on the bottom left you see this scan map. For example, if I would change that a view. Now in this case all these scans have been placed on or placed on the same surface, but if they are on different surface elevations, then you would see that they are on different elevations and so on. And I can very easily zoom in and out, or I could start pulling measurements very quickly inside VirtuSurf, so I get the distance since there's 3D coordinates in the background. So if you want to pull very easy measurements, then you can do that with VirtuSurf, and this is included in this PointSense plant package. Let me switch back to my presentation. I think it's this one, yes. So then we also work with catalogs, or these are integrated basically within PointSense plant. And we provide some standard catalogs, for example, this carbon steel 150 or carbon steel 300 and so on, which includes pipes, elbows, flanges, etc. And we also have the option to import full plant 3D specs and catalogs. So basically, if one catalog is not provided by Kubit, we can then import mostly any catalog that exists within plant 3D. Or you can also convert CADWorks or AutoPlan specs with the spec editor of Plant 3D. So there is a way to get your catalog inside PointSense Plant. We also added an import for steel structures or structural steel from AutoCAD, for example, the Tiein and so on. I'm going to switch to show you that. So here we now in Plant 3D, and if I go in this catalog manager here, I can basically go into Plant 3D import, and yeah, here I can load any catalog I want to, or I can load a specific spec, for example, carbon steel 300 and so on, and then it will give me a message, okay, that has been loaded, and then here I have my my Plant 3D specs or any spec you like, but you can also generate your own specs, for example. So that's very easy to do, and that's basically the core of this this software as well. So let me switch back. Okay. So now one of the main features is the pipe run analysis, which we are calling walk the run. And this is basically a semi-automatic approach to model pipe runs. We prefer this semi-automatic approach because if you model everything at once, then you have to clean up the mess afterwards. So this is more by basically making it semi-automatic. There's more intelligence behind that because you have to clean up less afterwards, and you just model it once and then you're done. There are various methods to detect and draw single components or entire pipe runs. So, and it's very easy to use tool, and we have improved the speed and accuracy of the pattern recognition that is behind this functionality. And yeah, we made some changes to the user interface to those of you who already have PointSense Plant, and we made it a bit easier to use. So, and we also added some additional methods to insert fittings, which also included a 3-point around the circle method. Some of you who are familiar with that know that it's sometimes quite difficult to get the direct connection, especially or direction of the next pipe, especially if you have not that many points. So we made some changes to that as well. Now I'm going to demonstrate you this walk the run. So basically we have a pipe run here, which is just clipped from a point cloud, and so you can see that in AutoCAD. If I change to the VirtuSurf now, you can see that this is basically just a heating room where pipes are going through, and let's say we would like to model these pipes within AutoCAD. So all I need to do is to start walk the run, and then I find a new run, and by just clicking 2 points on the pipe has been automatically detected, and you see on the on this window here there's a catalog in the background. So in this case it's an 8-inch pipe, and then we continue the search, so it automatically detects the ball valve, which I can now place on the axis. It automatically detects the elbow, then the next pipe. So everything works very smoothly and very fast. There is some interaction needed, but not that much actually. Here the reducer, I can place that very precisely if I want to then the T. Then I can extend, for example, this pipe. If it hasn't been extended automatically, I can manually extend this pipe to the next, where the next change basically in the point cloud is on the pipe run, and then it automatically detects the elbow as well. Then there's another reducer and another elbow. So that's very easy to do, and it allows you to do many different things with the modeling. So in this case, I need to continue this walk the run on a different, on the other side of this T branch here. And again, I just say click continue, and then I can specify the other pipe to guide the software towards the correct direction. And then it finds the elbow automatically. So everything works very easy, and then it detects the ball valve again. And then I can say insert and continue, place it precisely again, and then the pipe. And so this is my quickly generated 3D model of this pipe run you've seen previously directly in AutoCAD. So now an interesting fact is this model is very easy to do, but there's a difference between the Brownfield and the Greenfield. So because in this case we have as-built documentation, and the design software is basically expects different has different constraints. Basically there's coaxial cylinder axis or standard objects and so on, which means if there's minor changes in the modeling, which can happen, then we need to generalize these let's say simple mistakes or errors as such in order to make it consistent with the design software. And therefore we have a concept called apply constraints, and we have improved this concept as well. And the idea is basically it fixes lines automatically. So you can see on the bottom left that this would be a result of the local modeling, and there are some gaps which you haven't seen yet, but I will show them to you in a second. And so you can align those fittings and lines automatically so it complies with your design software. And the advantage of that is as well, it allows you to perform walk the run a little bit faster, so you have to take less attention to accuracy, but in the end you still get an accurate result. And finally, we want something like this so that these small gaps are closed. And it has been changed, so it's able to accept more complex configurations, and the algorithm has been improved to make it more consistent with the design software requirements. So this is an example here showing this. So this is the same pipe run we've just modeled, and we'll be zooming in on this section now on the T. And you see there are some gaps, and these gaps are actually not wanted, especially if you, I don't know, if you want to do some planning or something with that, and you run gas or liquid through that, then you would have a problem. So we need to fix this with our apply constraints tool. So it's very easy to use. Just click apply constraints. You have two options basically here. First, you select your pipe run. It automatically knows which pipes are connected. Your two strategies. Strategy 1 is more prioritizing the position of the pipes, and strategy 2 is the one that more prioritizes on the object definition. And this is basically what we want if we want to go to a design software. When we start the apply constraints, we would get an error message if there was a mistake or like a big change. But in this case, we just we're going to click apply constraints in a second, and if you have a look at this gap of the T between the elbow and the T, this will be closed in a second. So if I click that, so this basically has been closed now and is consistent with the requirements of a design software. And you see that the model is still intact, so there haven't been made large changes. They were only minor, but they were very important. So now we're basically ready to export these things. So the modeling was easy, the apply constraints was easy as well, and we have the option to export this into the center lines or plant 3D objects, from where we then can generate isometrics or part lists and so on, which is something you can then do in your design software. So yes, since I've shown you, you can use Plant 3D catalogs, you can directly export to Plant 3D, or you can export the center lines to other packages such as CADWorks or AutoPlant. So this is here a demo showing this. So we just click export. At first, I'm going to export to to polylines and tagging objects. So it will give me the center lines and also generate me an inscription of the pipe run that we've just modeled. So you see the green line here is the center line, and if we zoom in, you can see, okay, which components do I have here, and from that I can generate a part list and so on. So that's very easy to do, and again, you're directly in AutoCAD, so it works with any AutoCAD except AutoCAD LT. And if you do have Plant 3D, then you can directly export to Plant 3D. So you see that these objects here are now Plant 3D objects, and I'm directly in this design software. For example, I could now change the ball valve here at the top. So you can change this component based on your catalog. So if I just want to make that a different valve, then I can very easily do that, and I can also change it back. So any modification I want to do, I can do very easily within AutoCAD Plant 3D. Or for example, I can use this run and continue my pipe routing. So this is now AutoCAD Plant 3D actually, and so it's difficult sometimes not to mix the two up, but you see the workflow is very easy to go from the point cloud into your design software. So we also have the option to generate tie-in points in combination with VirtualSurf, and then we can export these results into HTML or XML. This is just something I'm going to show you now. So here we have an example of VirtualSurf on the left, and on the right, let's say we want to model the tie-in point of this pipe going in there, and let's say we want to model the elbow as well, and then to get the tie-in point. So again, just clicking 2 points. So here we have this pipe, then it automatically detected the elbow, and so let's say now we want to measure the tie-in point to the valve because that has to be removed or something like that. So all we need to do is to use this pipe. We could also use a flange now, but we just use this pipe and extend this pipe exactly to the face of the flange, and we can click that directly in VirtualSurf. So we click on the face of the flange, and now this pipe has been extended directly to the face of the flange, and then we can, since we now have the axis of this pipe, we can directly measure the tie-in point in here, and we can also use our tagging module to get the coordinates or the positions of that. So I just click with the object snack directly on the axis, type in tie-in point, and then I should get my coordinates. Here they are. So that's very easy to do, and you can generate reports, give it to your engineer, and so on. So now we are coming to the steel, which has been improved significantly. So we can fit single or multiple steel into the point cloud. Again, we can use catalogs or any, we can use profiles from catalog or generate our own profiles. So yeah, as I showed that before, you can use standard libraries or create your own, and you have multiple options to adjust and edit these beams, and the speed of that has been improved. And we added some post-editing options and also have an apply constraints for steel now, which I'll be showing in a second. So here's another example of this steel. So this is a point cloud outside, and we can see under these pipes there is some steel, structural steel, and let's say we want to model that. So this is just using the features of PointSense Plant to clip out the area of interest, and then we use this steel catalog here. There are many profiles, L-shaped, I-beams, and so on, and I select the profile I want to fit, and then I click again just 2 points into the point cloud. Here's my steel profile, and I can very easily extend this. So there are very easy options to do that. Then I fit the other steel. If I want to, I can also use VirtuSurf in combination with that. So I can click in VirtuSurf, 2 points on the steel profile. And again, you can see on the right-hand side that the steel profile has been fitted. And if I continue that now, I get more steel beams. Yeah, so this is just showing that there are others. And now this is a very simple model, but what we want is that the gaps are basically closed, and therefore we've added some post-editing features. So let's say I want to make this a complete model. I can very easily extend these steel beams. I just select them, click OK, and then select the other steel beam, and then they are easily extended to the steel beam I want to extend that. So the workflow again is very easy, and here I don't need to work within the point cloud anymore. I just concentrate on my 3D model. So this is just showing this. Or I can also use another option. For example, if I want to extend a single beam, I can just click on that beam. So there is another extend options, extend steel to point. I click on the beam and then extend this beam, for example, to another one. Or another option, which is apply constraints, would be if you adjust everything at once. So it's similar to the apply constraints for piping. You just select everything and automatically it snaps everything into place, and it's also now aligning the axis properly. If I zoom in here, you can see that the axis of the beams is aligned properly, and they're also connected now. So if you want to export that to something else, then you can very easily do that. Okay, and this is just showing the complete model inside the point cloud again. So, okay, and last but not least is the tank analysis feature that we've added recently, because there was a lot of interest. This is actually similar to the feature you've seen before from Jana in PointSense Heritage. I think it's a very nice tool and easy to use as well, and adds a lot of benefit. So we can unwrap point clouds for easier analysis, color code by deviation, something you've seen before, and you can generate very nice reports from that, depending on what type of output you want. For example, if you want a grid or a polyline, or if you want just an XYZ table, depending on what type of person you are. Some people want more tables, others more pictures, anyway. And you can calculate volumes as well, and this includes the calculation of if you have dead wood in your tank, for example. So this is a nice example showing this workflow. This is a very nice point cloud of an outdoor tank. So we can rotate this point cloud. Then we use the PointSense tools to clip out this tank. So then this tank is being isolated basically, and then we fit a cylinder into that tank. And based on this cylinder, we now want to measure the deviation of that tank. So this is very easy. So you just click on the modeling extension, analyze cylindrical part, and you select the cylinder and also a slitting point, which is basically a point where the point cloud is cut in half basically. You have different options here, as Jana showed before. You can add a deviation factor in order to make your result visibly a little bit better to understand. And you can generate several reports, and you can save this point cloud, the unwrapped point cloud as well, for example, call it deviation. And then this generates basically a 3D solid that you can see as a wireframe or as a solid if you want to. And then you also have the option to show that as an unwrapped point cloud or as a grid in this case, which shows you the deviation, or you can overlay the unwrapped point cloud. And if this is not enough, you can also color code it. So you have a more color-coded view, and you can see in here that the tank actually has been deformed quite a bit. It's a bit exaggerated because the deviation factor was 3, but anyway you start seeing that some of the plates of the tank are actually pushed outwards or inwards the tank. And now I can also go, for example, with this result into Excel and generate a report for that. So this gives you basically the the deviation values or the circumreference and the slice volume and the total volume. Or if numbers are not your case, then you can also generate nice graphs such as this here. So this is basically showing the tank height and the deviation of this tank in a nice graph. So again, this tool is very easy to use. And so the last thing I want to mention, we also have a clash detection feature, but I'm not going to show that now due to the time limit I have been given by Katrin. We also have a clash detection tool that you can use and many other features. So just in a nutshell, PointSense Plant basically is very fast, intuitive, accurate, and efficient. So that was my presentation for PointSense Plant, and many thanks for your attention.